Oh, the smell, oh boy. Oh. Last but not least, epilogue. What is mathematics for? To make fun of engineers. Whoa.
Papa Flammy's Advent Calendar.
Here.
Welcome back to another video. Whew. Stirling engine, stop it. I've had something lying around for ages in my mailbox, and today I will finally unbox it. It's amazing. Video not sponsored by anyone, so do not fear. This is a review video. We are going to review the most prestigious graduate math text in history, in modern history. It's going to be absolutely amazing, but before we get started, don't forget to check out today's STEM deal on the Advent calendar. We got Hagoromo Full Touch Des, discounted by 10% over on STEM merch. Check it out, link in the description. This right here is the legendary chalk being produced in Korea now, but not in Japan anymore. And also don't forget to check out my personal Teespring shop, 10 to 15% off everything using the code for 2069 at checkout. Now, this piece that I'm having right here is something very special, and I can't wait to finally open it up. It's going to be absolutely amazing. This right here is one of the most renowned graduate math textbooks that you can find out there, and I think it's going to be absolutely amazing. And I'm not going to wait any longer now. I'm going to unbox it. Also, by the way, I'm going to give this book away to one person commenting and liking the video here, okay? I'm going to sign this book too. Gotta give it away. Deadline is till the end of December, and if you commented and liked the video, then I'm going to pick you, maybe, okay? I'm going to announce the winner at the end of the month. And now we are going to dive into the main meat. Okay, let me open it. Let me open it up. Oh, the smell, oh boy. Oh. Can you already guess what it is? No, you probably can't. This right here is the Manga Guide to Calculus. This is what we are going to take a look at today, and it's the most renowned graduate math text. Yeah, and yeah, we are going to see how it performs today. I'm actually quite curious how it's going to teach you calculus. I have no idea, never looked at a PDF or like. I bought it, and like mentioned, I'm going to give it away. Comment and share and like the video, that would really help out a lot. And now we are going to dive into the Manga Guide to Calculus. Can't wait. Let us see how this thing performs. So the cover is already quite inviting, if you ask me. So we have my most favorite waifu, blue dress Chan at the front, and we also have a business guy and a typical glutton here. And this manga has been drawn by Hiroyuki Kojima and Shin Togami, as it seems, and it has been published by Becom Co. Limited. And let us see what is on the inside. Ooh, it looks like a book to me, as it seems. Oh wow, Nani-chan! Oh! Praised for the Manga Guide series. Highly recommended. The Manga Guides definitely have a place on my bookshelf, and maybe on yours in a few weeks from now. The series is consistently good. A great way to introduce kids to the wonder and vastness of the cosmos. It's calculus. Have they even read through the book? I found the cartoon approach of this book so compelling and its story so endearing that I recommended that every teacher of introductory physics in both high school and college consider using it. American Journal of Physics on the Manga Guide to Physics. Oh, I see. So this is just reviews to the whole Manga Guide series. There's a lot out there. Manga Guide to Statistics, so force mathematics, etc. And okay, now it makes sense that they talked about the cosmos. And now we are going to take a look at the main meat of the book. Oh, integral. Oh, look at that, our main characters. Oh, this is so hella cute. Yeah, I don't care. Okay, so we got a bunch of contents in here, and let us see. So the first chapter is going to deal with let's differentiate a function on Nietzsche, shall we? And the next one is let's learn differentiation techniques. Oh, I wonder what Nietzsche is going I need to stop. It's going to teach me today. Let's integrate a function. Oh, I can wait for the integration. This is going to be amazing. And then using the fundamental theorem of calculus, I'm terribly sorry. Let's learn integration techniques once again. Let's learn about Taylor expansions. That's amazing. Partial differentiation. I hope they are going to solve the Navier-Stokes equation in here. That would be absolutely amazing. Oh, it's so amazing. Okay, and then we have a bunch of other things. Preface. There are some things that only Manga can do. I don't care. Prologue. What is a function? Okay, so we have confused Blue-Terrestrian running around here. For ease of understanding, some figures are not drawn to scale. How? What? Why are you doing this? You need to draw it to scale, otherwise I can't do mathematics. Goodness. Oh, angry grr. Oh. The Asagake Times Sandacho office must be around here. Just think, me, Noriko Hikima, a journalist. My career starts here. It's still a small newspaper and just a branch office, but I'm still a journalist. I work hard, ganbare! Am I right, my fellow weeps out there? And then she arrives somewhere. Okay, what is a function? We are still asking ourselves the question. Okay, and then we have fellow fat boy lying around, like the bunch of garbage that he is. And then we have the guy who's always the main actor in each and every hentai. Okay, I can already see him licking the pussy in a few chapters from now. It won't get any better than that. True journalism, yeah, I agree. I can see F. Okay, F. Okay, let me see. Well, you majored in the humanities. Yeah, yes, senpai, that's true. I've studied literature since I was in junior high school. You have a lot of catching up to do then. Let's begin with functions. Functions? Oh, math? What? When one thing changes, it influences another thing. A function is a correlation. You can think of the world itself as being one big function. Whoa. A function describes a relation, causality, or change. As journalists, our job is to find the reason why things happen. Okay, so she doesn't know that you can express it like this. For example, assume X and Y are animals. Animal X goes into F and turns into animal Y. Assume X is a frog. Ah, that's a Fresh Toad Walker reference. It seems this guy is really educated. He knows about Fresh Toad Walker. If you put the toad into box F and convert it, tadpole Y comes out of the box. Yeah, I mean, yeah, okay, if you define F like, okay, let's move on with that, okay. I wouldn't explain shit like this to any person at all because it just sounds absolutely unlogical to put a toad in there and get a tadpole out on the other side, but never mind, okay, we are going to go with the flow. The F stands for function, naturally. F like function. Speak with me, F for function. F is used to show that the variable y has a particular relationship to x, and we can actually use any letter instead of y. No, F. You can use any letter. That's forbidden. In this case, F expresses the relationship or rule between a parent and an offspring. A parent is the toad. You put it into F and you get an offspring out. Okay, so they introduced functions, and now there's actually, oh, this is kind of cool. So yeah, they are doing casual manga stuff, okay, fucking each other, I don't know. And then we have causality as the subject. Okay, you can put stuff into here and basically evaluate a function at a certain point, and you can give it a certain name like G instead of F. Then we have changes. Changes can be expressed via functions too, that is good. And unit conversion. Yeah, obviously you need to have the right units after you put something into a function. Then you also have graphs and how to put relationships into graphs as pairs of x and y coordinates. And yeah, okay, I think this part isn't actually that bad. It's better than the manga part. I mean, naturally, I wouldn't call this really education, this manga part. This is just to make things a tiny little bit more accessible, it seems, even though the function example wasn't really accessible. I wouldn't use that in any case. But yeah, other than that, I think it's good that they have some kind of some kind of overview at the end of each and every chapter, it seems. Oh, and even an exercise for the reader. Find an equation that expresses the frequency of Z chirps per minute of a cricket at X degrees Fahrenheit. Okay, cool. I think that's a cool exercise. And now let's differentiate the function. Okay, so as usual, we got the pussy licking going on. And then he's explaining prices, it seems, on the market. And we also have, now he's expressing the correlation between prices and the year. And he is actually giving examples of decreasing and increasing linear functions at that. That is cool. And this is actually really good. This is really good. He's talking about approximations. Calculus or analysis in itself is the science. It's the mathematics branch of dealing with approximations and making them really rigorous. And it's good that he introduces this topic to her. And now that we can approximate certain points with a trend line. Also, he's talking about convex and concave. This is also good, meaning we have certain slopes that is changing over time, like parabolas. This is good. So they are actually introducing a bunch of concepts. And now he's talking about slopes. Okay, and he's actually using the tension interpretation of the differential, which is really good in my opinion. This is a really good way to introduce it to beginners. That way you can use the difference quotient, which he actually introduces. No, this is the relative error. Okay, so he's dealing with the error at first. And they are trying, I mean, it's still the same thing. They want to make the error as small as possible, such that you actually get the derivative out. It's the best approximating tension line to the curve. Okay, then we get a bunch of other stuff. That's a long chapter as it seems. Okay, then we have some more functions. Now he's actually using epsilons right here, which is really good. So for the difference quotient, it seems he's using epsilon instead of limit. No, epsilon is the error right here. And he's probably going to say, let epsilon be really, really small. So let's let it go to 0. And then we are going to get the derivative out. Then we got some more manga action, I don't know. And then calculating the derivative. This is what I want to see. So basically, we are having the relative error. This is what I thought. This was the difference quotient. And then they are going to find out the relative error, and they are going to make it as small as possible, this error. It's the best approximating tangent line to the curve, and this results in the difference quotient. And this is good. That's a very nice approach. I like that. For the calculation of the derivatives. We got a bunch of other things here, quadratics, linears. Very nice introduction, and once again we got an exercise at the end. We have a function f of x and a linear function g of x, blah blah blah. It is known that the relative error of the two functions approaches 0 when x approaches 5. A obtain f of 5 and b obtain f prime of 5. For f of x being equal to x to the third power, obtain its derivative f prime of x. Yeah, good stuff. And now we are going to learn about differentiation techniques. I'm going to skip a bunch of things, a bunch of pages, and I think what he's going to do is, he's going to introduce the summation rule, which does make perfect sense. I wouldn't call it a summation rule. It's a linear operator. Differentiation is a linear operator, so he's introducing one part of the linearity of the differential operator. Also, this right here is it's a theorem. It's not the intermediate value theorem. I can't remember what it was called. Mean value theorem. That right here is the mean value theorem. And he's also introducing that. That's a good thing. And he's also probably going to introduce the product rule and all the like, one after another. Yeah, so we have the product rule up here. I'm pretty certain that he's also going to introduce the quotient rule. Ah, cool. Here we have the derivative of an nth degree function, so an nth degree polynomial. And once again, he's giving a very nice overview together with the power rule and also constant multiplication, meaning he's introducing the second part of the linearity of the differential operator. And I'm pretty certain that we are at the end of this one. And then theorem, the conditions for extrema. Okay, yeah, this right here is really important, making use of the concave and convex property of functions and using basically the second derivative's approximation as being a parabola. I don't know if you have ever done this before. You can approximate the first derivative using the best approximating tangent line and the second derivative with the best approximating parabola. And this way you can find out if it's concave or convex. And then you are going to get a bunch of theorems out of analysis that have to do with maxima and minima and all the like. And yeah, then we have the derivative of composite functions and all this crazy stuff. Okay, it actually gives a really nice overview. So what I kind of like about this book, it's really not the manga part, but what I like is the overview they give at the end. I think you can actually get some nice intuition out of this whole book. If you just start out with calculus and you want to get a nice overview of all the most important theorems and the like, that this book is maybe something that you should get yourself. On the one hand, it looks kind of funky, okay, next to your, I don't know, quantum dabbing books that you have lying around in your bookshelf. And now we are going to integrate a function. I'm pretty certain that he's going to introduce integration using area under curves, okay, density is constant. And then area under curves, approximating those using Riemann sums. Riemann sums being called just rectangles. Okay, and then we are going to sum all of these up. And then we are going to go from the approximation to the exact value. Once again, and this is going to give you your Riemann sums. So yeah, this is the standard approach you should take to understand integration at first, Riemann integration. And yeah, then he has a nice graph right here. I actually think that the graphs look rather okay. I don't like the typesetting from time to time here. I don't know, it just doesn't look like computer modern form, so from LaTeX, but I don't know. And then we have a strict explanation of step number 5. And then they are going through all the integration bits. Now she's drunken, so we are probably at the part where he's going to lick his pussy pretty soon. And now they are going to go through a real example, the supply curve. Yeah, once again, fundamental theorem of engineering calculus. That's a fine theorem that they are covering here, exercises. And then let's learn integration techniques. I think they are going to give you a lot of integration techniques like the king property and Leibniz rule for integration, all this good stuff. No, they are not going to do so. They're going to give you the substitution and all the like. So now we are at unit circle, probably has to do with the fact that they want to introduce trig substitutions, which does make perfect sense. Okay, good. So yeah, they are introducing trigonometric functions. Oh! I have not seen this before. They are deriving the antiderivative of the cosine using the unit circle. This is curious. I'm going to look into this further once I'm done with the video. This is actually quite interesting. Maybe I'm going to get a video out of that. Yeah, this is cool. That's a cool thing. I have not seen this before, I believe, using quarter of the unit circle to derive this. Okay, so we got some more growth rates and the like, and then integrating inverse functions, getting natural logs probably out using graph interpretations and all the like, integration by parts, more applications of the fundamental theorem of engineering, exercises. And now we are at Taylor expansions. Okay, let us see how that pans out. So Taylor expansions, probably telling her that we want to approximate it using a finite polynomial at first, and then we are going to approximate it even better using an infinite polynomial, making the error smaller and smaller, probably introducing the geometric progression and also geometric series then. Yeah, okay, and then we get some standard formulas for Taylor expansions. Let me see what the last few chapters are actually going to be. Okay, after Taylor series expansions come partial differentials, meaning we are probably going to introduce multivariable functions at first, it seems. Yes, they are going to do so using Crest once again. And from this point onwards, now we are dealing with planes and shit, so all the stuff, surfaces in general. And now everything kind of escalated because now we have the partial derivative, which is actually quite hard to handle in analysis. If you have ever done real anal, it's pretty complicated to get like the multivariable quotient rule and all of that out. Those theorems involve heavy errors and stuff like this, and it's just really hard to deal with if you ask me. I didn't like that part of analysis very much. Yeah, but they are introducing the relative error yet again, which is in two variables now. And from this point onwards we can find maxima and minima and all the stuff again. The regular stuff you always deal with. Now we got some funky notation, and then we are at the end of that chapter, and I think this should actually nearly be it. Last but not least, epilogue. What is mathematics for? To make fun of engineers. So I just want to give you a nice little overview of the manga guide to calculus. I believe it's something you can actually look at from time to time. It gives you a nice overview at the end of each chapter in regards to integration techniques and the like, differentiation techniques, what differentiation actually is, graph interpretation, and all this stuff. I think it's not even too bad. I still want to give it away, like mentioned before, but I was glad that I was able to look into here a tiny little bit. Like mentioned before too, I'm also going to take a look at this one chapter yet again with the unit circle, because this actually interests me a tiny little bit. But I hope you did enjoy this video. I hope you did enjoy this little overview. Oh yeah, what would I give it? From 1 to 10 hentais, I think I'm going to give it, since it's a fun little book, it's not there to take it too seriously. I'm going to give it 5 out of 10 hentais, okay? I think this is totally enough. Now I freaked everything up. Other than that, if you did enjoy this little overview of the manga guide to calculus, make sure to subscribe to the channel and share this video around and to like it, etc. If you want to participate in the giveaway, make sure to comment on the video as well as to like it. Sharing would also be pretty good. And other than that, check out StemMerch for our advent calendar deal that we are running over there. And up until the next video, I wish you guys a flammable day. Ciao. And now I'm going to grab my loop and take a look at my krill blue dress chant a little bit more. See ya!